Imagine waking up in a room the size of a walk-in closet, shared with 5 other people, somewhere in the middle of the Pacific Ocean, with no phone signal, no GPS notification, no ability to call home, no bank access, no news from the outside world, no way to leave, and no certainty of when you will see land again. And then imagine that this is not a survival scenario. It is simply Tuesday. There are approximately 5,000 people living this reality aboard a Nimitz-class aircraft carrier at any given moment, compressed into a vessel roughly 1,100 feet long and 250 feet wide, operating in waters that could be hostile, in conditions that could shift from routine to catastrophic in under 4 minutes. And doing so not despite the absence of the modern world's support systems, but because of it, because the entire engineering philosophy behind a nuclear aircraft carrier is built on a single foundational constraint. The ship must be capable of surviving completely alone, indefinitely, without any of the infrastructure that the rest of civilization depends on. And that constraint, that single, immovable design principle, is what transforms a military vessel into something far more strange and far more precise than most people ever consider. It becomes a city that replaced freedom with discipline, and found, in doing so, a system so tightly engineered that failure in any one part of it creates consequences that cascade through every other part almost immediately. Which raises the question this entire structure is built to answer. How does a floating city of 5,000 people sustain itself, psychologically and physically, when the modern world simply does not exist for it? Start with the most basic system, the one that feels least military and most human, because it reveals the design logic faster than anything else: water. A Nimitz-class carrier produces its own fresh water through a process of distillation, converting seawater into potable water at a rate of approximately 400,000 gallons per day using waste heat from the ship's propulsion systems, meaning the carrier does not carry water from shore, does not request resupply for water, and does not depend on any external source for the most fundamental biological requirement of 5,000 human beings. If you were living aboard this ship and the distillation system failed, you would not notice it immediately. The reserves would hold for a calculated window. But within that window, the entire behavioral structure of the ship would begin to compress. Showers would be rationed first. Cooking operations would reduce. Medical facilities, which require sterile water in quantities most people never think about, would begin triage protocols for what procedures could continue and what would have to wait. The laundry system, which processes thousands of pounds of clothing and linens per day, would stop, and 5,000 people living in tight quarters without functioning laundry, with reduced showers, with a medical system under constraint, would begin to experience a psychological pressure that has nothing to do with fear of the enemy and everything to do with the slow erosion of the small dignities that keep human beings stable under isolation. And this is where civilian logic collapses, because on land, water failure is a crisis that gets fixed by calling someone, and on a carrier in the middle of the ocean, it is a crisis that gets fixed by the people already inside it, or it does not get fixed at all. This is the foundational pressure the entire ship is engineered to distribute, absorb, and resolve internally. The water system connects directly to a system most people overlook entirely when they think about military vessels: waste. A carrier of this scale generates waste at a volume that would overwhelm any civilian municipal system if it were not managed with the same engineering precision applied to every other survival function. The ship operates under strict environmental regulations that prohibit the discharge of untreated waste within specified nautical distances from shore, which means the carrier must process, store, or treat everything it generates: food waste, human waste, mechanical waste, chemical waste, through internal systems that have no external outlet until the ship reaches an approved zone or returns to port. The food waste alone, generated by kitchens that serve upward of 18,000 meals per day across multiple mess decks, operating in staggered shifts to accommodate a crew that operates on a 24-hour cycle with no true downtime, is processed, while compacted, and managed through a logistics chain that most people would associate with a small city's sanitation department rather than a warship. If you were working a 12-hour shift in the engineering spaces and the waste processing system backed up, the consequence would not be abstract. It would be immediate, physical, and demoralizing in a way that undermines operational readiness faster than almost any mechanical failure, because human beings operating under extended isolation are psychologically dependent on the maintenance of basic environmental order. And the moment that order visibly degrades, the effort required to sustain discipline increases sharply across the entire crew. The designers understood this. The systems are redundant not just because they are critical to survival, but because their failure is a psychological event as much as an operational one. Here is what most people never consider. The food system aboard a carrier is not simply a matter of storage and cooking. It is a precision logistics operation running under conditions that have no equivalent in civilian supply chain management. The carrier carries enough food to sustain 5,000 people for extended deployments, which means refrigerated storage, dry storage, and frozen storage operating in carefully managed temperature zones within a hull that is also generating enormous heat from propulsion, aviation operations, and the mechanical systems of thousands of individual people working in spaces that were never designed for comfort. The supply officers managing this system are not thinking about menus. They are running consumption modeling, tracking inventory depletion rates against projected deployment length, calculating the nutritional requirements of a crew performing physically demanding work across extreme shifts, and doing all of this without the ability to order more, call a supplier, or substitute a missing ingredient from a nearby store. When a specific food item runs out weeks before expected, the adjustment is not made by going to a store. It is made by recalculating every meal plan across every mess deck for the remainder of the deployment, which sounds administrative until you understand that food variety is one of the primary psychological levers used to sustain morale under isolation, and that a crew eating the same meals repeatedly for weeks begins to show measurable declines in focus, patience, and cooperative behavior, not dramatically, not in ways that make the news, but in the subtle accumulation of friction that experienced commanders recognize as a precursor to the kind of interpersonal breakdown that degrades operational effectiveness far more than any single mechanical failure. And this is where the pressure intensifies, because the systems feeding and sustaining 5,000 people are running simultaneously with the systems sustaining the aircraft, and the aircraft are the reason the carrier exists, which means the logistics of human survival are always operating in competition with the logistics of operational readiness, and the resolution of that competition is not a negotiation. So it is a hierarchy encoded into every workflow, every shift schedule, every resource allocation decision made aboard the ship. The aviation fuel system alone, JP5, stored in tanks within the hull, pumped through a distribution network to flight deck fueling stations, managed under strict protocols because aviation fuel aboard a carrier is one of the most controlled substances on the ship, given its fire risk in an enclosed environment, represents a parallel supply chain running beneath the human supply chain, and both of them are running beneath the power system that makes all of it possible. A Nimitz-class carrier is powered by 2 nuclear reactors producing steam that drives 4 propeller shafts and generates electricity for every system on the ship. Lighting, ventilation, water distillation, cooking, medical equipment, navigation, communication, aviation support, and the thousands of individual electrical demands of 5,000 people living and working inside a steel hull. And the nuclear propulsion system is the point at which the carrier's self-sufficiency reaches its most extreme expression, because a carrier fueled by nuclear reactors does not need to refuel for the duration of its operational life, which spans decades, meaning the fundamental energy constraint that limits every other vessel on the ocean simply does not apply here. If you were to remove nuclear propulsion from the design and replace it with conventional fuel, the entire strategic logic of carrier independence collapses. The ship would require fuel resupply every few weeks, which means it would require a supply chain, which means it would require a predictable logistics corridor, which means it would be trackable, and a trackable carrier is a vulnerable carrier, and a vulnerable carrier cannot project the kind of presence that the entire system is designed to project. The nuclear reactor is not a weapon. It is the architectural foundation of isolation survival. But the reactor introduces its own constraint layer, one that most people outside the naval nuclear community never fully appreciate. The human beings operating it must be among the most precisely trained technicians in any military on Earth, and they must perform that work under the same conditions of isolation, fatigue, and psychological pressure as everyone else aboard the ship. Which means the safety margin of a nuclear reactor operating in the middle of the ocean is directly dependent on the sustained cognitive performance of people who have been awake for extended hours, who have not spoken to their families in weeks, who are living in spaces that offer almost no privacy, and who know that if they make a certain category of error, the consequences are not recoverable in the way that most mechanical errors are recoverable. The training pipeline for nuclear qualified sailors is long, rigorous, and deliberately designed to create people who can perform precision work under conditions that degrade precision. And even so, the reactor systems are engineered with redundancies and fail-safes that assume human error will occur and build containment around it, because the design philosophy of the carrier does not trust any single system, human or mechanical, to be infallible. And that philosophy is what separates a system engineered for isolation from a system engineered for convenience. Convenience tolerates single points of failure because help is always nearby. Isolation cannot. The medical system makes this visible in a way that almost nothing else does. A carrier deploys with a fully equipped medical facility, including operating rooms, intensive care capability, dental, psychiatric support, and pharmacy. Not because the Navy wants to provide comprehensive health care as a benefit, but because the alternative is that a sailor with appendicitis 800 miles from the nearest port dies, and a dead sailor is an operational failure. An operational failure propagates through the system in ways that compound. The medical department is staffed by military physicians and corpsmen performing procedures that in civilian life would occur in purpose-built hospitals with specialist backup available by phone. And on a carrier, the specialist backup is the person standing next to you, because there is no other option. Psychiatric support, which in civilian institutions is often treated as secondary, is treated aboard carriers with a seriousness that reflects what command leadership understands about long deployments. That the psychological integrity of 5,000 people living under isolation, rigid hierarchy, physical confinement, operational pressure, and communication blackout is not a soft concern, but a hard operational variable. And that a crew whose psychological cohesion begins to fragment becomes progressively less capable of executing the precision tasks that every system aboard the ship requires. The berthing arrangements, racks stacked 3 high in compartments designed for efficiency rather than comfort, with curtains providing the only privacy available to most enlisted sailors, are not an oversight or a cost-cutting measure. They are the product of an engineering trade-off in which every cubic foot of space has been evaluated against competing demands, and the result is a living environment that requires the people inside it to develop a psychological tolerance for proximity and a behavioral discipline that would be unusual in any civilian context, but is simply the baseline condition of life aboard the ship. The communication system deserves its own analysis because it is simultaneously one of the most sophisticated systems on the carrier and one of the most deliberately constrained. The carrier maintains the ability to communicate with Fleet Command, with aircraft, with other vessels, and in limited ways with the outside world. But those communications are not equivalent to civilian connectivity. They are not always available, and they are subject to operational security protocols that can restrict or eliminate personal communication for periods that extend from days to weeks, depending on mission requirements. If communication went dark during a deployment, not as a failure, but as an operational decision, 5,000 people would be severed from every personal connection they maintain with the world they came from. Managing that severance through the routines and structures the ship provides which is why routine itself is one of the carrier's most important systems. The shift schedules, the meal times, the maintenance cycles, the drills, the physical training requirements, these are not bureaucratic impositions. They are the psychological architecture that prevents the kind of temporal disorientation and social fragmentation that isolation produces in unstructured environments. Human beings without routine under isolation do not simply become inefficient, they begin to lose the shared behavioral framework that makes coordinated action possible, and coordinated action is what every system aboard the carrier requires at every moment. Discipline in this context. Why is not the opposite of freedom? It is the infrastructure that makes survival possible when freedom has been deliberately removed by the design requirements of operating alone in hostile waters. The command and control layer, the networks of officers, chiefs, and department heads managing the simultaneous operation of aviation, engineering, logistics, medical, security, and crew welfare, functions as the carrier's nervous system, and its design reflects the same constraint logic that governs every other system. There is no external authority to call, no consultant to bring in, no decision to defer until more information arrives from outside. Every decision that affects the survival and operation of 5,000 people must be made by someone already inside the system, using the information already available, within the time window that the situation allows. This is not exceptional leadership. It is the baseline operational requirement, and it is what the entire training and organizational structure of a carrier's command is designed to produce. The chain of command is not a hierarchy of prestige. It is a fault-tolerant decision architecture designed to ensure that if any node in the system fails, the decision-making capacity of the whole is not lost, and that architecture is tested constantly, not through simulation but through the actual operational demands of running a city that cannot call for help. What emerges from examining these systems together, water, waste, food, power, medical, communication, command, is not a picture of a weapons platform, but a picture of a civilization built on the engineering of self-reliance, a structure that has solved, in steel and protocol and human training, the problem of surviving completely alone in an environment that is actively hostile to survival. The carrier is the most extreme expression of a design philosophy that most people encounter only in fragments, in backup generators, in emergency reserves, in disaster preparedness kits, but which the carrier has taken to its logical conclusion. Building every redundancy, every system, every behavioral protocol around the foundational assumption that the modern world will not be available when it is needed most. And what that produces, in the people who live inside it, is something that looks from the outside like discipline, and from the inside feels like the only rational response to a set of constraints that leave no other option, a replacement of the informal freedoms of civilian life with a structured system precise enough to keep 5,000 people alive, functional, and operationally effective for months at a time, without resupply, without communication, without the infrastructure that the rest of civilization has decided it cannot live without. There is one system aboard the carrier that has not been examined here, the one that manages the psychological integration of sailors returning from long deployments back into civilian life, the transition from a world of total structure to a world of total choice, and the question that system raises about what discipline does to a person over time, and whether the engineering of survival leaves permanent marks on the people who lived inside it, remains, for now, unanswered.